Welcome everybody. In this video we're going to be talking about data distribution, particularly Gaussian distribution and Kurtosis skewness. And if your data is not normally distributed, we will see how can I fix them. We'll basically use two transformation methods. One is log, another is Boxcox power transformation. Okay, so now let's begin our process. At first we are starting by just importing our necessary libraries. Okay, fine. Then I'm gonna import the data. This is just some water quality. There are some water quality parameters. Okay, we'll see how we can use for data distribution. At first I'm going to plot a normally distributed data. So here just np.random normal. Here 0 means mean of this data, and 1 is standard deviation. So we are creating a data set that has mean of 1 and standard deviation, mean of 0 and standard deviation of 1, and this is the size. Okay, let's plot it. Here you can see that this is a Gaussian distribution where 50% of the data is right side of this mean, that is 0, this 0, and 50% of data is distributed around the left side of this mean. And the probability of occurrence of a data is highest in this area around this mean. Okay, and this is a tail. On the right hand side it's tail, and this is also another tail. And when this tail is deflected towards right or left, then we call it skewed data. If the tail is extended towards the right side, we call it positively skewed data. On the other hand, if the tail is extended towards the left side, we call it negatively skewed data. And remember, in a normally distributed data, mean and median and mode are equal. They are equal. But in skewed dataset, if it is right skewed, mean is greater than median, and if it is left skewed, mean is less than median. Let's plot one right skewed data. Okay, here I have plotted manganese. Now you can see over here that this tail is extended towards right, so it's a not right skewed data. It's not normally distributed. Now if we see the mean and median of this data, you can see mean of manganese is 0.65 while median is 0.38. It's not very huge difference, but for this data set it's actually huge because our lowest value is around 0 and highest value is 5. So mean 0.65, median 0.38. It's a bit skewed. Alright, so there's another thing called Kurtosis, which measures the actual shape of your data distribution. Actually the top of your data distribution, its top is highly sharp or not sharp, such things. Okay, and Python has built-in functions for measuring skewness and kurtosis. And skewness of greater than 0.75 is considered considerably or significantly high, so we need to treat those parameters. Here you can see manganese has 2.5 skewness, arsenic is 6.5, so those parameters should be treated before you run any regression model, any linear regression model. So now there's another function called Kurtosis method, so you can measure kurtosis also. Okay, now that we know that which parameters are skewed, so we need to fix them. There are very popular method is log transformation method, and it's just np.log and provide your, in parentheses, provide your data you want to transform. So just see now it's log transformed. Now if your data contains any 0, then log transformation will not work. What you have to use is log plus 1, so 1p plus 1. So now it will work fine. And if you want your previous data format back, what you have to use is just np.exp. so if you use log 1p, you have to use exp minus 1, but if you use only log, then just exp. Okay, fine. Now we want to transform our data, just not only one column, we want those columns have skewness greater than 0.75. So for that, what we will do is df.skew, and we will extract those values, those column names which have skewness greater than 0.75, and remember to use these absolute values. Dot index is for because we want just column names. Okay, now let's see our data frame. Now you can see over here all of the columns which have skewness greater than 0.75 or our threshold value are now transformed. Now let's see the skewness again. Okay, arsenic is still a bit skewed, 0.79. Manganese is okay, it's nearly or absolutely normal. Nearly normal. Okay, fine. Now you can again see the mean and median. What I said is for normally distributed data, mean and median is same, and here they are pretty close, 0.94, 0.96, pretty close. Okay, you can also plot them. You can see log for figure size is a bit big, 13, 5. Okay, so this is before log transformation, this is after log transformation, and you can see after log transformation, well depth, this feature is now nearly normal. Okay, this nitrate is not actually transformable. Okay, fine. So you can see that log transformation doesn't work good on all parameters. Here iron is still skewed, fluorine is still 0.98, significantly skewed actually. So what we will use is Boxcox transformation. So at first you have to import Boxcox transformation from SciPy. You can transport Boxcox, or you can import from sklearn.preprocessing, import power transformer, and from power transformer we will use Boxcox transformation. There are many ways of Boxcox transformation. Okay, now again we have to import our data. I think yes, fine. Now from power transformer, and here this is the method, because power transformer includes two methods, Boxcox and Johnson. We're going to use Boxcox. Okay. Dot fit transform dataset, just those skewed columns. Okay. Now let's see the skewness. Now you can see a significant change in skewness. No parameter except nitrate is skewed now. All of them are less than 0.75. Okay, fine. Now I can see the kurtosis. Not that bad. Okay, you can also plot them for Boxcox transformation. This one nitrate is not a good fit, but this sulfate, you can see well depth, very good fit here. Chlorine also well transformed. Chlorine is highly positively skewed, but now it's quite good Gaussian distribution. Sulfate also. Okay. So in this Boxcox transformation method, we used different lambda values for different parameters. Actually, different best fitted lambda values for different parameters. And if you want to know those lambda values, so what you have to do is you have to at first you have to create power transformer object, and you can store it in a variable box, just or anything you want, then fit it to your data, and after that box.lambdas will provide you all those best fitted lambda values. Now you can see for first parameter best value was 0.6, and the last one it was minus 0.41, that is for arsenic. And there's another way of Boxcox transformation, and it's what in this case you can use just only one single lambda value for all of the parameters. By this way you can do that. Okay, that's it for now. If you have any question, let me know in the comment section down below. Okay, I'll see you in another video. Bye.